Okay, now we're at part 3 of the notes for section 1.7. Let's finish up these types of problems. So now we have the cubed root of the square root of 729 x to the 11th. So if we go back to our properties here, look at the third property. If you have the mth root of the nth root of a, you get the same as what? The mn root of a. So all you're going to do is multiply these two numbers together. Okay? All right, so we have what? 3 times an understood. Understood what? 2. 3 times 2 is the 6th root now of 729 x to the 11th. All right, now 729, well, might be more challenging to factor, but, you know, use your calculator to do so. All right, if you use your calculator, this is odd, keep dividing it by 3, see what happens. Okay, so again, if you have any questions or concerns, reach out to me. All right, but 729 actually is a number that's a power of base 3. 729 is actually 3 to the 6th, okay? And so if you put 729 in your calculator and kept dividing by 3, you do so 6 times. So anywho, this is the same as what? I'm actually going to rewrite this thing from radical form into exponential form. That's another option you have if, you know, if the situation exists that might be conducive to doing so. Okay, so now, what do we get? Well, again, 729 is the same as what? 3 to the 6th. Okay, so now we have 3 to the 6th. That's what this is. 729 is 3 to the 6th. And then again, what are we really doing here? We're distributing this exponent 1/6 through everything. So you get 3 to the 6th times, or excuse me, to the power of 1/6 times x to the 11th to the power of 1/6. Okay? And so what do you get? Well, these cancel. Power of a power, you multiply. So these are gone. You get 3 to the 1st, that's just 3. And this, again, power of a power, you multiply. X to the 11 over 6. And you are finished. This is expressed in rational exponent form, okay? If you really wanted to, you could rewrite this from rational exponent form to radical form by keeping the 3 in front, and then let's review this. What does x to the 11 over 6 really mean? It means the 6th root of what? X to the 11th. Oh, so wait a second. Are we finished with this? Is this in simplest radical form? No, it is not. So maybe I took a little bit longer on this. Maybe this is convoluted in your opinion. And I understand. I could agree with you. But I'm just showing you different things you can do. Okay? Some people can look at this and just tell me the answer, boom, right out of the gate. Okay? It's going to be what? 3x times the 6th root of x to the 5th. But anyway, let's say we're here now. It's not in simplest radical form. We are not in simplest radical form. Why not? Because we have 11 x's underneath this 6th root. So because there's a 6 here now, what we're doing is looking for groups of 6 x's. Again, this means we have 11 x's, right? So we have at least 6. We have 11. So for every group of 6, we pull one x out in front. So we get 3x. So one group of x's becomes one group of 6 x's becomes 1x in front of this 6th root radical. Okay? So how many x's do we have left over? If we pulled 6 x's out in front because of this and wrote 1x, which is correct, you'd have how many x's remaining? You'd have 5 x's remaining. Now we're finished. Okay? Because this exponent, 5, is less than this index 6. Okay? And this will kind of bridge the gap into what we're getting ready to talk about in some ways with the last part of the notes. Okay? All right. So, I'll tell you what, let's go ahead and just review this problem now based upon what we just did. Okay, now I know it may seem like there's a lot going on, and there is a lot going on. These can be tricky, but if we understand those properties, then we should be in good shape. Okay, so 1 over x to the 16/15. Well, we're not allowed to have a fractional exponent occurring in the denominator. So there's different ways to do this. I could rewrite this in radical form, and then I would understand if I rewrote it in radical form that I'd have 16 x's under the radical, okay? So if I rewrote this in radical form, I would get this. Now, I'm not saying I would actually do that, but if I wanted to, I could. Just stay with me. I would get this. I'd get the what? The denominator is the index, so the 15th root of x to the 15th. So if I do it this way, that's fine. I recognize I have one more x under the radical than this index. So I could rewrite this now as what? X times what? Still the 15th root of just x. So those two things are the same, all right? They're the same, but I still have a radical involved in the denominator. So we're not allowed to have a radical in the denominator in order for something to be in what? In simplest radical form, all right? So what's a better way? What's a better way, at least in my opinion, to handle something like this, to put it in simplest radical form? Well, here's how I would do this. So stay with me. I'm going to leave this in exponential form, and I'm going to show you how to change this, all right, which is not in simplest radical form, into what is called SRF, simplest radical form. So all you have to do is the following. We are going to multiply the top and the bottom of this expression by the same thing. Okay, you have to do that to keep it the same. You have to multiply it by an expression that's equivalent to 1. And here's what the expression is always going to be equal to, okay? It's going to be the same base here, raised to an exponent, the smallest possible exponent, the smallest possible fraction that when added to this given fraction gives you a whole number. So what's the smallest fraction that when added to 16/15 will give you a whole number? That's going to be 14 over 15. 14/15. Is this the smallest possible fraction that when added to 16/15 gives you a whole number? Yes. Look, we're already at 1 and 1/15 here, right? That's what this means as a mixed numeral, 1 and 1/15. So how many more 15s do I need to get to another whole number of 2? I need 14 more. So this now, in simplest radical form, even though it's written as an exponent, is this. So this is now complete, all right? This is perfect. I mean, if you really wanted to rewrite it using a radical, there's your 15th root on top, x to the 14th, all over x squared. Okay, there's definitely a lot more going on in this section. I understand that. Again, feel free to reach out to me anytime if you have any questions or concerns. But so going from here to put it in simplest radical form to there. All right. All right, this is a challenging section historically. So hang in there. Let's do one last thing here, okay? What we want to do here is rationalize the denominator, just like I showed you, okay? These are hopefully going to be easier than what I just did. I hope. These are more like what you're going to see on the test, okay? If you can handle these three, you're going to be in good shape. All right? So this is the most basic type. If you have 1 over the square root of something, you're allowed to multiply this by 1, like I just told you in the previous example. Well, let's make that 1 the same as radical A over radical A. Why would I do that? In this specific instance, because radical A times radical A is, guess what? A. So the goal here is to remove the radical from the denominator. All right, let's rock and roll. This one's going to be a piece of cake. If you multiply the top and the bottom by square root of 2, what do you get? 2 times radical 2. And then what's square root of 2 times square root of 2? Same as square root of 4, or just 2. And if you can simplify further, go ahead and do so. So the 2's cancel, and you're left with radical 2. Simplest radical form. All right, number 2 is a little bit more challenging, but look, the idea here in number 2 is just like this one. All right, it's very similar to this one. Again, get comfortable with exponential form versus radical form, okay? They mean the same thing, they just look different. They mean the same thing, they just look different. All right, I'm going to go ahead and keep it in radical form for this one and show you how to do that. So what we want is to get rid of this entire thing that's now occurring in the denominator. Okay, we're going to do that in the same way we handled number 1. We have to come up with an expression that is equivalent to 1 that when in the denominator position, when you multiply together here, you get rid of this cubed root. You get rid of the radical completely. So take a look at this. You now have 5 squared. That means you have 2 5s under the cubed root. You need 3. So here's the thing. Keep the index and the radical intact. They do not ever change. So do that. That's how you're going to start this. If this is a cubed root, these had better be cubed roots. Otherwise, you can't multiply them together. All right, so we need how many more 5s here to make this 5 cubed? We already have 2, so we just need 1 more. And if you want to do 5 to the first to be clear, that's fine. You need 1 more 5. So I'll show you what this actually produces. It produces 8 times the cubed root of 5 to the first, understood, in the numerator. And in the denominator, it gives you this, the cubed root of 5 cubed. If these are the same, what's happening? If these are the same, then they cancel, okay? If the index is the same as this exponent, they cancel. So the whole point of doing this, adding 1 more 3, is so that these do cancel out, and you're left finally with this expression in simplest radical form. Finished with number 2. All right, moving on to number 3. All we want to do here in number 3 is get rid of this radical 2x. So just multiply the top and the bottom by radical 2x, and that will accomplish that goal. So here's what we get. We get 4x squared times the square root of 2x. And then in the denominator, we get what? 3. That's by itself. 3 what? Well, 3 times radical 2x times radical 2x. They're identical. It's a square root, so you just get 2x. Now, can we cancel anything? Can we reduce anything here? Yes, we can. This becomes a 2, and this becomes just a 1. We have x squared over x. X squared over x, this becomes an x to the first, and this x is gone. So our final answer is going to be what? It's going to be 2x times the square root of 2x all over 3. Finished with number 3. Again, any questions or concerns, please reach out to me. Thank you so much. Have a good day.